In this video, we're going to work with rational expressions. A rational expression is a ratio of two polynomials. We have one over here, or a fraction where you have a polynomial in the numerator and a polynomial in the denominator. So we're going to be simplifying, multiplying, dividing, adding, subtracting rational expressions. In number one, we just want to simplify this rational expression. Okay, and we're going to do that. We're going to do that by dividing the denominator into the numerator. The denominator does divide into the numerator, so let's do that. We're going to first divide into the first term, and so we have minus 12 divided by minus 6 is positive 2. Now the powers of x cubed divided by x squared, that's x. And y squared divided by y is y. Let's go to the second term. 18 divided by minus 6 is negative 3. And then x squared divided by x squared, those cancel, and y divided by y, those also cancel. So we have 2xy minus 3. In number 2, again, we just want to simplify. And here we have two quadratics. So in order to simplify, we have to factor and see if we have common factors. And then we can cross off common factors. So basically, that's how we simplify. Factor, top, bottom, cross off common factors. Okay, so let's start factoring. Okay, we're going to factor by reverse FOIL in the numerator and denominator as well. Okay, so here we'll fill in with 2xx for that 2x squared term. And let's see, we have a subtraction symbol here, so the signs are going to be different. And we want to put 2 factors of 15 here and here. So let's try 5 and 3. Okay, let's put a 5 here and a 3 here. All right, one will be positive, one negative, and we want to get a minus 7x in the middle. So let's try a negative here, positive here. Always check that you have the right middle term. All right, so let's do that. Here we have the outer, that's minus 10x, and the inner is plus 3x. Minus 10x plus 3x gives us that minus 7x. Okay, so this is correct. Now let's go ahead and factor the denominator. Okay, first times first, that would be xx. The signs are the same because of the plus here, and because of the negative here, we know they're both minus, minus, minus. And here we're going to put 5 and a 3. 5 times 3 is 15. Check that middle term. Minus 5x minus 3x is a minus 8x, so that's good. Now notice we have a common factor in the numerator and denominator of x minus 5. So we'll divide top and bottom by x minus 5, or basically just cross off those common factors. And this rational expression reduces to 2x plus 3 divided by x minus 3. In number 3, we want to do basically the same thing. We want to factor numerator, denominator, and see if we have any common factors so that we can simplify or reduce this rational expression. Now look at the denominator, 25 minus x squared. That's a difference of 2 squares. And let's factor it as a difference of 2 squares. Here we have 5 squared minus x squared. Start with the 5. 5 plus x, 5 minus x. It's important that we start this factorization with 5 because the polynomial that we're factoring starts with 25. Okay, if we reverse the order, we wouldn't have the correct factorization. We'd have the opposite sign, the factorization with the wrong sign. All right, now let's factor the numerator. Okay, xx, signs are different. All right, and we'll try 5 times 2. We want to get a minus 3x in the middle. So let's do this. Let's check that we have minus 5x for the outer, 3x for the middle, and that gives us minus 3x. Okay, now let's look for common factors. Well, we do have an x minus 5 and a 5 minus x. Now, these are subtractions in the opposite order. So the quotient of these two is equal to negative 1. 5 minus x is minus x minus 5. All right, so when we reduce, because of the different ordering in the subtraction, we must remember to replace with a minus 1. Okay, so this simplifies to minus 1 times x plus 3 divided by 5 plus x. Okay, now let me just caution you about one thing. We see that when we have subtractions in different orders, the quotient is equal to minus 1. However, if we have a sum, if we have something like 5 plus x divided by x plus 5, that's equal to positive 1. All right, in other words, these cross off. Those are equal because we can add in any order. That's a commutative law. However, subtraction isn't the same. In number 4, we're multiplying two rational expressions. So we do this just like we multiply ordinary fractions. We multiply across the numerators and across the denominators. But we always try to reduce before doing that multiplication. So let's do that. Let's first try to reduce. And again, we reduce by factoring and crossing off common factors. So we'll factor whatever we can. Starting with this numerator, we can factor out a 3. All right, so that's 3 times x plus 2. And here in the denominator, we have a difference of 2 squares. That's 5x plus 1 times 5x minus 1. All right, here we have a 5x plus 1. That we can't factor anything out of that. And here we have 5x plus 10. Let's factor out of 5x plus 2. And now we just look for common factors. So I see an x plus 2 here and an x plus 2 here. Common factors in numerator and denominator. I can cross that out. All right, here's a 5x plus 1 and a 5x plus 1. We can cross that out. Okay, so what are we left with? Let's just look carefully. So in the numerator here we have a 3. And here in the denominator we have 5 times 5x plus 1. Sorry, 5 times 5x minus 1. Now, we could just leave it like this, or you could multiply through by that 5. Just like that. And number 5 again, here we're dividing. We're dividing two rational expressions. So we're going to use the division rule for fractions, which says that we take the reciprocal of the second fraction and multiply. All right, so we're going to change this to a multiplication. All right, the first fraction remains the same. And now change the multiplication and take reciprocal of the second of the divisor. And now we'll continue by factoring and looking for common factors before we multiply. All right, here 9 minus x squared, that's a difference of 2 squares. That's 3 minus x times 3 plus x. 5x minus 15, factor out of 5, so we have 5 times x minus 3. And here we have 15x squared. Okay, now let's look for some common factors. All right, so we see the x minus 3 and the 3 minus x. And remember, these are subtractions in different orders, so when we can cross them off but replace with a minus 1. All right, we also have, let's see, here we have a 5 and a 15. We can reduce that. And here we have x cubed, x squared. So we could reduce that also. We could just divide top and bottom by x squared. And I think that's it. Let's just carefully look and see what we have left. Okay, here I see a minus 10x in the numerator. And here in the denominator we have 3 plus x times 3. So that's the product. In number 6, we're adding fractions, so we have to get a common denominator. And what we do is first we concentrate on the coefficients. And we want a common denominator of 36, 12, and 18. So we're looking for the smallest number that all three divide into. We'll start with the largest number, the 36. And let's see, well, 12 does divide into 36, and 18 does divide into 36. So 36 is good. Let's use that. And now we'll look at the powers of x. Well, all you do is pick off the largest power and put that in the common denominator, x to the 5th. Include that. And that's our common denominator. Remember, when finding a common denominator, think bigger, not smaller. Largest power. Okay? Because x squared goes into x to the 5th, x to the 5th divides into x to the 5th, and x also divides into x to the 5th. All right, now in order to get equivalent fractions, we want to multiply numerator and denominator by a factor that gives us this denominator. So I see we have a 36 here and a 36 here, but here we have x squared, and here we have x to the 5th. So we have to multiply by x cubed to get that denominator, top and bottom. So the numerator here is 5x cubed. Now, we want an equivalent fraction. We want the second fraction to change into an equivalent fraction with this denominator. All right, so we have to multiply by 12 by 3 to get that 36. And that's it, just 3. Because we already have the x to the 5th. So we have a 21 over here, 3 times 7. The third fraction, let's see, we want to multiply 18 times 2 to get that 36. And we want to multiply x times x to the 4th to get that x to the 5th. So we're multiplying top and bottom by 2x to the 4th. So that's the numerator here, 2x to the 4th. Let's just add these up. We have a common denominator. Put everything in one fraction. And just add those numerators. We don't have any like terms, so we just put plus signs in between. And that's the sum. In order to emphasize this method, I added one more problem to our review, 6a. All right, we're adding these fractions. We want a common denominator. So again, let's do the coefficients first. We have 15, 30, and 20. Start with the 30. Well, 15 divides into 30, but 20 does not divide into 30. So let's try doubling 30. We get 60, and that works. 15 goes into 60, and 20 goes into 60. So 60 will be part of our common denominator. Now the powers of x. X cubed, x fifth. Take the largest, x fifth. Remember, when finding a common denominator, think bigger. Okay, powers of y fifth, y fourth, y squared. Take y fifth. So that's our common denominator, 60 x to the fifth, y to the fifth. All right, let's figure out the numerators. Here we need an equivalent fraction with this denominator. Okay, so we have to multiply 15 times 4. X cubed, we have to multiply by x squared. And we don't have to multiply y to the fifth. So this numerator is 8x squared. Okay, here we need to multiply 30 by 2. We have to multiply x by x to the fourth. And y fourth we have to multiply by y. Okay, so 2x to the fourth y times 1. So that's our numerator, 2x to the fourth y. Third denominator, we have to multiply 20 by 3. X to the fifth, we don't have to multiply. Y squared, we have to multiply by y cubed. Okay, so 3y cubed. So this numerator is 9y cubed. Now we have a common denominator. Just put everything under that common denominator. 60 x to the fifth, y to the fifth. And add these numerators. Again, no like terms, so we'll just put plus signs in between. And that's the sum.